Section 2.3 Other types of equations. So we will see literal equations, polynomial equations with higher degree, rational equations, and equations with radicals, and equations with rational exponents. Now let's start with literal equations. A literal equation is an equation that has several letters or variables in it. So basically these are mostly formulas coming from the applications. For example, A equal to pi r squared. Here A represents the area of a disk with radius r. This is coming from geometry. Again, this is another one. P equal to 2L plus 2W. This is the perimeter of a rectangle. It's a rectangle formula. Okay, the perimeter of a rectangle. Now we want to solve this one for W. So basically you want to isolate this W. So how can you isolate W? You send this one to the other side, so we have this, and then divide both sides with 2, then we will end up with this. So this is solution. Now let's look at another equation. Now we want to solve for solve A equal to pi d squared over 4 for D. So we want to get what is D. So we want to isolate D here. How can you isolate? You divide, you multiply both sides with 4. So we don't want this, so we multiply by 4 and then divide. Okay, and also let's divide. Okay, then it will be 4 cancel out, and then 4a is equal to pi d squared, and then we don't want this also because we want this alone. So divide by pi, because it's multiplication, so we divide. So we end up with this. D squared is equal to 4a over pi, and this is something like x squared is equal to b type thing. So how do you solve it? There are two solutions. You take the square root of b, you put plus minus, so we have two solutions. This is how we solve it. Now let's look at this example here. It says solve the literal literal equation for t. Okay, we want to get t. Now for this reason, you have to make all t's one side, all other terms this side. Okay, now we want to do this. Now how can we do it? We basically do the sending them like t here and t here. I want all t's here, all t's here. So send this one here as minus, send this one as plus. So what happens is we get a t plus c. Okay, minus t is equal to b plus 2. Okay, and then it's t times, now next, t is a common factor, so you can write it as t times a minus c equal to b plus 2, and then divide a minus c both sides. You have this. So this is what we do exactly. If we have like 15, what happens? You divide by 3 both sides, right? We do exactly the same thing here with the letters here, with this expression, and it turns out t is equal to b plus 2 over a minus c. Now let's see the polynomial equations with a higher degree. Now a polynomial equation is a polynomial equal to 0 type equation. So, or it can be changed to this form, like for x cubed plus x minus some number here minus 3 equal to 5. You can make it to here, and you can make this one 0. Now, solution factoring is okay, these are not all the solution methods, but these are the solution methods we can apply in this class, in this course. Factoring or change of variables. So let's solve this problem. First thing is you have to put it in this form here. So we want it to be 0. Some students do it this way. They divide by x squared. So I will say this start is wrong. So you cannot start like that. If you start like that, what happens? Now, if you start by solving them x squared, there will be cancellation. After the cancellation, you will get some equation, and when you solve it, you will get minus 4 and 4. What's wrong with it? Okay, this is wrong. Let's see what's wrong. The wrong thing is, okay, you will have to use the factoring. When you use the factoring, you end up with x squared here and x to the 4. So send here as minus, you will have this one. In the factoring, you will see 3x squared minus 16, like here, x to the 4th, x squared common, 3 common. So we have this, and when you factor this one, it will be x minus 4 times x plus 4. So we end up with 3 possibilities. X squared equal to 0, x minus 4 is equal to 0, and x plus 4 equal to 0. And then when you solve it, you get x equal to 0. You got x equal to 4, and you got x equal to minus 4. So you see the solution set is this. So you see what's the difference? 0 is lost here. 0 is lost. So don't do this, like dividing x squared and doing this, doing this cancellation with x squared, it's you lose 0. So the correct, you lose one of the roots here. Don't do it. Now let's do this try and check. Please stop the video and try to do it by yourself. Okay, I will do it. X, and I see there is a common factor here, x, and this is the least power. The least power is 1, so least power is 1. So I will take x to the first, then x squared plus x minus 2. Then I will factor them. If you factor it, I mean, you can try this. I think this will not work, and then you can try. It will not work, so you can say then plus x and minus 1, so it will work. So then this will be x plus 2x minus 1. Equal to 0. And then we use zero factor property. And we have one option, x equal to 0. One possibility is the middle term is, the middle factor is 0, or x minus 1 equal to 0. And when you solve it, you will get x equal to minus 2 and x equal to 1. So we have these possibilities. And when we write all the solution set, we put all the possibilities, all the possible solutions. Okay, let's look at this problem. Sometimes we use change of variables. So this question is one of them. Can we factor it? It's not easy. But one thing we can see is like x to the 4th and x squared. One is the square of the other one. So you see x to the 4th, we can write it as x squared. So in this case, it's better we replace x squared by u. Then, what's the reason for this? The reason is when you put this here, u and u, you will get a quadratic equation that looks easy. Let's say it looks familiar. We know it. We know how to solve it. We can do the factoring or use quadratic formula. Okay, quadratic formula is it has guaranteed solution. So if you this guarantees the solutions. Factoring. How about factoring is not always uh, good. I mean feasible. Anyway. So then use the quadratic formula, use here 1, A is 1, A, B is this, and C is this, and then put this here. You use the quadratic formula after some job. We get this one, okay, we get these two, like U is equal to 4, 1 plus minus 2 square root 2, and then change this one, okay, it's coming from here, and then you change U by x squared. So what we did here is first we did this, and then again now in this part we did this. We get back to x squared. So U is an intermediate step here. We use the U and then throw it out. Throw it. And then when you solve this one, what happens? You have two solutions here. Okay, for now, let's look at here. We have two solutions. And then for each one, we have two solutions. And for this one, we have two solutions from each. And then when you divide all these solutions, we get 4 solutions. So this gives all the possibilities, like 2 of them here, and with the pluses and minuses, we have 2. So then we give all these solutions. Now let's do this try and check exercise. Now let's solve the equation x to the 6th minus 7, x to the 3rd, and minus 8. And there is no common factor between these three terms. So it's hard to factor this. But let's check for a change of variable. We have x to the 6th and x cubed. So as you see, x to the 6th is x cubed squared. And now it's better to use this change of variable u equal to x cubed, and then we can convert this one to u squared minus 7u minus 8 equal to 0. And then okay, can we use factoring now? Yes, we can use factoring. U minus 8 and u plus 1 equal to 0. Okay, check it. Okay, I leave it to you. You check it. And then we have by zero product property, we have two possibilities. One is u minus 8 equal to 0, which means u is equal to 8, and the other one is u equal to minus 1. And then now you get back to, again, x cubed. Again, u equal to x cubed. Last time we did this x cubed is equal to u, and now we are trying to get back to x cubed. Now x cubed is equal to 8, and what's the solution for it? X equal to 2, and here x cubed is equal to minus 1, so what is x? You can say this is minus 1. So the solution set will be minus 1, and 2. Now let's look at the rational equations. The rational equations has the rational terms like that. And we have lots of polynomials in the numerator or in the denominator or some other place. The method is to convert the polynomial, to convert this equation to a polynomial equation by using LCD. LCD is the least common denominator. Okay. Now, but we have to be careful here. The solutions that make the denominator zeros are excluded. So these are called extraneous solutions, and they're excluded means we don't accept them. Now let's look at this example. Now look at this equation. In this equation we have two fractions and their difference is equal to x. Now we don't want these here. Okay. So how can we get rid of them? So by using LCD. Now, what is the LCD of 3 and x minus 1? There's nothing common between them, so directly the LCD is, least common denominator is 3 times x minus 1. And the next thing now is to multiply both sides with this LCD. So you multiply, and what happens is 3x minus 1 times 3x minus 1 divided by 3. You will get some cancellations here. So this is the reason we are multiplying with this. You know, then when you multiply 3x minus 1 with this one here, 2x over x minus 1, and then you have this simplifications. So after these simplifications, you got x minus 1 times 3x minus 1, 3 times 2x, and then 3x, here 3x minus 1 times x. Now, okay, this is important. Now, this is what I told you. And then we end up with this. And then the next thing is we will expand them. So we have to be careful about the multiplication here. And here on this side. And then we will end up with 3x squared and minus x and minus 3x. That will make negative 4x and then plus 1. And minus 6 is equal to 3x squared minus 3x. Okay, please check this part here. Check. Do it, okay? And then try to send, okay, 3x squared, and you send them here as minus, so they cancel out. And try to collect all terms one side, like send 3x as here plus, and then here plus goes there as minus. This is minus 7x is equal to minus 1. Anyway, then we have this one. Okay, then when you solve this one, as I told you, negative 7x equal to minus 1, divide by minus 7 both sides, you will get plus 1 over 7. And then the next thing you have to do is you have to check this in the denominator, so it doesn't make a problem. So 1 over 7 minus 1 does not make 0, so 1 over 7 is a good solution, is not extraneous solution. So there is no problem. This 1 over 7 does not make denominator 0, so the solution is x equal to 1 over 8. Let's try to solve this. Try and check exercise. Please stop the video and try to do it by yourself, and then watch my solution. Now, the first thing is we want to get rid of the denominators. So one way to do it is, the best way to do it is find the LCD. So to multiply with LCD. So LCD of x minus 1, x plus 2, and 4. Or you can also say LCM. Anyway, LCD is, if there's no common factor between them, no common factor, then automatically the LCD is x minus 1 times x plus 2 times 4. If there is no common factor, you can directly multiply. Then step 2 is multiply both sides with the LCD. And then you can distribute. You can write this as you can write them. I mean, you can also do it this way. Okay, it doesn't matter. So it's like, you know, this is the reason. If you have multiplication, you can combine them in the denominator, so they're same. So now let's do the cancellations. Now we have x plus 2 times 4. So by the way, they don't make 0, by the way, they make 1, but dividing and multiplying with 1 doesn't change the result, so we don't take care, we don't pay attention to it. Then we expand. Multiply. Now you can, okay, there is a square here, so it looks like a quadratic equation, so there is no x squared, so it's better we make it in standard form. 4x, 4x is 8x anyway. Send all of them to the other side. Then this makes now we have step 3 now. We got this this 0 equal to 5x squared, and okay, this makes 3x, and this makes negative 14. Okay, then we will solve this one now. You could we could have skipped some steps, but I didn't want to. I wanted to show every step. So this is the reason for this video. I know how to do it, but some of you, some of the students, they really don't understand what's happening. So I want to show every bit of everything. Okay. Okay, we can solve it in two ways of factoring or quadratic formula. Okay, this guarantees the solutions. This we have to spend some time on factoring. So, but anyway, I don't want to deal with this factorization issue. I will solve this one with quadratic formula. It's A is this, and B is this, and C is this. So X is equal to plus minus, no, sorry, this is minus B. So minus 3 plus minus square root B squared, which is 3 squared, minus 4 times A, and then C divided by 2 times A. So we have X equal to 3 plus minus 9 plus 280. So if you calculate, and then we end up with this 3 plus, it's here square root 289. I mean, you can check, this is 17. So we have 17 plus minus 17 divided by 10. So we end up with these two solutions here. One solution, and the other solution is minus 17 over 10, so which makes negative 14.10. And if you do some calculations, also you can, after the simplification, you can say, anyway, you can say it's 7 over 5. You find the solutions. Now, and the next step is check if they make the denominator 0. Step 4, check if they make a denominator 0. Now, 2 obviously does not make x minus 1 or x plus 2 0. Okay, does not make 0. And obviously negative 7.5 over negative 7 over 5 does not make x minus 1 or x plus 2 equal to 0. So then you say, so what I mean here is just like, when you put 2 minus 1, it's not 0. When you put 2 plus 2, it's not equal to 0. So when you will put them here and you see it's not 0, it does not make 0. So then you say step 5, you can say the solution set is 7 over 5 and 2. Okay, let's do another example here. Okay, surprisingly, we have the solution set, empty set. Okay, we will check it. Okay, it's okay. We know the solution, we know the final answer, but the important point here is to learn how to do it. Okay, let's look at this example. you check the least common denominator, and there's only one denominator which is common. We take the LCD as x minus 3, and we multiply both sides as you see here. Like we multiply everything with x minus 3. No, okay, there is no cancellation here, no simplification here. So then we end up with x 3 and this one. And then when you solve it, okay, you expand, and there's when you solve it, you get x equal to 3. You can check the steps here. X equal to 3, and then we check it in the original equation. We check it in the equation, so we see this is undefined. So what I mean here, this x equal to 3 makes x minus 3, the denominator, zero. So 0. So when you put here 3 minus 3, it's 0. So the denominator becomes 0. So for this reason, you don't take it as a solution. This is extraneous solution. So extraneous solution, you can take it as a fake solution. So it cannot be a solution. You say it's empty set. Now let's do another one. Okay, here we have another equation, and in this one we don't want the denominators here. So how can you get rid of the denominator? Use LCD, but obviously there's no other denominator here. The LCD, we don't talk about the LCD, it's just x. So there's only one fraction, so the least common denominator, you can take it as x. And then you multiply both sides with LCD, xx, so x, and then here they will cancel out. You will end up with this. Then solve it. Okay, like if you have x squared, so it's better you write in standard form, and then solve it by factoring. And here the factoring looks better because we have negative 72 and plus 1, and it's obviously 9 and minus 8. Okay, you can check this part. Check, please. And then we find the solutions here, -9 and 8, and then check the possible solutions in the original equation. You put them in the equation, and is there a problem, division by 0 problem? No. Okay, so here the main thing is here, when you put x equal to -9, so it's just -9 here, so there's no 0 problem. And for the 8, we have the same thing, so the solution is -9, 8. So as you see here, you can put here -9, it's okay. 8, okay, it's okay. So there's no problem, so the solution set is -9, 8. Let's do this, try and check example, try and check exercise. Please stop the video and try to solve it yourself first. We want to get rid of the denominators here, and in the denominator it's better to write them as a product of their factors, so factor them if possible. Then to get rid of them, you have to find, okay, the first step is you find LCD of x minus 3, and x minus 3 times x plus 3 is, okay, x is not common, so I will directly write x. X minus 3 is common, but the highest power is x minus, the first power x, so I will say 1 here. And this is not common, so I will directly put it here. So step 2 is to multiply both sides with LCD. And it's better you write here as x minus 3x plus 3, because it will help in cancellations. So then distribute, and I can have this one x minus 3. Again, I'm using this logic here, a times b over c is equal to a, b over c. So this is what I'm doing here. Okay, you can write them in parentheses. The binomials definitely, with two terms definitely, but you don't have to write this in parentheses. But anyway, x minus 3 times x plus 3. Then we have this cancellations here, and this one here, this cancellation, and this cancellations here. And we end up with 3 times x minus 3 times x plus 3 is equal to, okay, minus 2 times x plus 3. This makes negative 12 x times, okay, these are all 1 here, so we don't put them. Now 3 times x squared minus 9. Okay, so do you remember what I wrote here? 8 plus a minus b times a plus b. And it's a special product formula, and I do 2x squared, and then here minus. Okay, be careful, I'm multiplying with this and this, so it'll be minus 6x equal to negative 12x. And after doing that, we got 3x squared minus 27 minus 2x squared minus 6x equal to negative 12x. And we have x squared terms here, and they don't cancel each other, so I am writing this one in standard form. So when you have a quadratic equation, when you see the x squares, you can say this is a quadratic equation. So if the highest power is x squared, and then you say it's a quadratic equation, then you can try to write it first in standard form. Okay, these two make x squared, and then we have negative 6x and minus, okay, 7. And send this one to the other side. We will have, okay, we can put it anywhere, so I put it here because it's close to this one. So it becomes x squared plus x, 6x minus 27 equal to 0. And can we factor this? Okay, x and x, there's minus here, so it's at least one of them is plus, the other is minus. So but here this one is plus, so the big one should be with here. So 9 times 3, okay, it makes this. Yeah, okay, we got this one. Okay, good job. And then this one turns out to be x minus 3 times x plus 9. So here. Okay, I will write this one again. So x minus 3 times x plus 9 equal to 0. So this is 0, or the other one is 0. And here it gives x equal to 3. And here it gives you x equal to negative 9. Okay. These are the possible, okay, these are the solutions we got. Now, we get the solutions. So these are the possible solutions, okay, are, okay, these values, but check if x equal to 3 and x equal to minus 9 make a problem. Make one of the denominators zero. So let's check this one. So when you put here 3, obviously 3 makes a problem here and here. It's a problem. There's a problem because this makes it 0. 3 makes it 0. And then minus 9. Okay, minus 9 doesn't make any problem. So minus 9 doesn't make any problem here and here, and here no problem. So we say 3 is a fake solution, is extraneous. So the only solution is only 9. The solution set is only 9. Okay, sorry for this. I was in a hurry. Now let's look at this example. We have denominators here, x minus 1, x plus 1, and this is x squared minus 1. And you can write this one as x minus 1 times x plus 1. And we want to, in the solution, okay, the start is, we start with the least common denominator. The least common denominator of x minus 1, x plus 1, and x minus 1 times x plus 1 is equal to x minus 1 times x plus 1. So indeed, this is LCD of x minus 1 and x plus 1. It's x minus 1 times x plus 1 is this one, because we have this common, but we take the highest power, it's this. And x plus 1 is common, and we take the highest power, it's 1. So the least common denominator is this one. And the next thing here is we multiply both sides by LCD. So when you multiply this and this and this, okay, all of them with LCD, there will see you will see the cancellations here, and this one. Then next we have x times x plus 1, then x minus 1, and here, okay, be careful, okay, you have to put the parentheses here, and then there will be this 2. So then after expanding them, you got this equation here, x squared minus 1 equal to 0. Okay, you can do the intermediate steps, check them, and then when you factor this, you got 2 roots, one is minus 1 and the other is 1, and we check the possible solutions in the original equation. Now this 1 or minus 1 makes one of the denominators 0 in the equation. So here this 1, okay, here when you put in this term, so this makes like 1 over 1 minus 1, so there's 0 here. So 0, this is not accepted. So 1, okay, cannot be accepted. And when it comes to minus 1, okay, take minus 1 and look at here, check this one, 1 over x plus 1, and it will be 1 minus 1 plus 1. So you see it's 0. When you take the x equal to minus 1, it will be 1 over 0 here, so this is undefined. So this is also not accepted because they make the denominators equal to 0. So then we don't take them because they're extraneous. We call them extraneous solutions. Then we say the original equation has no solution. Then these were the only possible solutions, but they turn out to be extraneous. So we say the solution set is empty set. Now let's look at the equations involving radicals. The general strategy is get rid of the radical sign by taking powers and solve the equation. And one other thing here is eliminate the roots, okay, the solutions that do not satisfy the original equation. So there will be some extraneous solutions. So extraneous like fake solutions. Now let's look at this problem here. We don't want this square root, so this radical sign we want to get rid of this. So what can we do? We take the square. So don't do this one. Okay, so some students will try to do it this way. Okay, so taking square is okay, but this won't help. Why? Because it will give us a more complicated result. So this will give us a more complicated result. So this will 2x plus 7 and then minus 2x, and you know, it will be more complicated. A better way is to isolate the radical sign. They isolate the term under the radical, the radical term. Now look at here. The isolate means like leave it, write it alone. So here, take this one and send it to here. So it's x plus 2. And now you can take the power. So take the power of both sides. You know, you take the power of both sides. Now it will be 2x plus 7. And then expand this. Then we have an equation. And solve the equation by factoring if it is possible. Then by factoring you get these two solutions, 1 and negative 3. But we have to check if they're fake or not. Okay, are they fake? Fake. Okay, this is the problem. Now, okay, these are the steps here. Isolate the radical, and then square each side and get rid of the radical. Now, check the possible solutions and here in the equation. So what we do here is we'll put this here. You know, there are two solutions we found, like possible solutions. One of them is 1, the other is negative 3. And then we put 1 inside it, 1 inside the original equation here. And then we are asking if it is true. Is it true? Yes, it satisfies the equation. But when you take negative 3, the other possible solution, and put it in the equation, it gives you an interesting result here. Look, 2 times negative 3 plus 7. It makes 1, right? So we are taking the square root, so it makes 1. So we have 1 here. This is 1. We got 1 minus 3 is, you see here, minus 3 plus 3. So you got here 4. But here it has to be equal to 2. It turns out to be false. 4 equal to 2. It's false. So this is a fake solution. Then we say 1 is a solution, but not negative 3. So we write the solution set as 1. Okay, let's do this try and check problem. Here we have square root both sides. No need to put, send one of them to the other side. So here the hint, okay, we take the square of this and we get x plus 1 equal to 3x plus 1, and it turns out 2x equal to 0, and you get x equal to 0, and you check it. Check the solution. 0 plus 1, is it equal to 3 times 0 plus 1? Yes, it gives a true equality. Yes, this is 0 is a solution. So you say the solution set for this equation is, the solution set for this equation is just 0. Now let's look at this try and check example. Solve this equation. It says x minus square root 15 minus 2x equal to 0. And the first thing is like the isolate the radical. So isolate means like take this one and send it to the other side. So it will be in minus 2x. So we wrote radical on one side and the other is one side, and then take the square of both sides. When you take the square of both sides, then you got this one. Next, we have a square here. So if this is a square, I mean x squared, if we have a square here, this is a quadratic equation, and the best way to deal with a quadratic equation is to write it in standard form. So make it equal to 0, like send all of them here. We have 0 here, and then you can factor or use the quadratic formula. Okay, solve this one, solve it, and then you can do x plus 5 times x minus 3. Okay, check it please. Okay, I will not tell you how to do the factoring anymore. Just you check it please. Stop the video and try to see how we get it. Then we have two possibilities. One of them is x plus 5 is equal to 0, which gives us x equal to negative 5, and this is x equal to x minus 3 is equal to 0, so we have x equal to 3. Then we have these two solutions. And the next thing is like check if they are extraneous or not. Extraneous means fake. You can take it fake anyway. Check if, okay, now how you put them in the equation, like x equal to 3, then put them in the equation 3 minus square root 15 minus 2 times 3. So let's check it. Is it equal to 0? So this is the main problem. 3 sorry, this is 3 minus 15 minus 6, which is 3 minus square root 9, which is 3 minus 3. Yes, we got 0, so it's okay. And 3 is a real solution. Throw x equal to 3 is a solution. Now let's check the other one. X equal to minus 5. Minus 5 minus square root 15 minus 2 times minus 5 equal to 0. It's minus 5 minus square root. It's 25 here. So as you see, negative 10, which is not equal to 0. So this turns out to be an extraneous solution. So x equal to negative 5 is extraneous solution. So it means we don't take this. So we don't take it. And the solution set is the solution set of this equation is just 3. Equations involving rational expressions. Sometimes the equations will have expressions with rational exponents, like this one, for example. So we will see how to solve such problems, and also some other types. Now the key information here is this one. If if x is a real number such that x to the m over n power is a real number, then the x to the m over n power to the raised to the n over m power is equal to x if m is odd, and it's equal to the absolute value of x is if m is even. So this is something like x squared, so the x cube, the cube root of x is equal to x, and this is something like, if it is like 4 x squared, its absolute value x. So we have the same logic here. If we have odd number here, odd, then it will be equal to x, and if this is an even number, so we will have the absolute value of x. The key idea here is this, and okay, to solve such equation, like, we will raise both sides to the power n over n, n over m. So here this is m over n, this you will take the n over n, n over m, and this part also raise both sides to the power n over m, so both sides. And then depending on m here, you will change this one to x or absolute value of x. So you see here, if m is odd, I mean even, we have absolute value. If m is odd, we have x. And of course, c to the n over m should be a real number. If it is not, then there's no real solution. And here, for example, if someone is taking the square root, okay, 3 over 2, for example. So what does this mean? It means you're taking the square root of -1 to third power, or -1 third power square root. They're both here. This is equal to square root -1. So this is not real number. So this is not real, and this is not real. So it cannot be a real number sometimes. So we have to be careful if c is positive or negative. Sometimes there might be no solution. And the other thing is there might be some extraneous solutions. So the solution should be checked in the equation. And to solve such equation, we will do some factoring, and maybe we can use some substitutions here. We can use also this substitution, because the idea here is this one and this one. When you look at here, this is the x m over 2n squared. So it's squared, so the 2, they will cancel out, we will get this one. So we have the middle term, and it's square here, so it looks like a quadratic equation, and we will use the properties of quadratic equation to solve it. Anyway, you will see it in the example. Now let's look at this example. Solve 4 times x to the 2 thirds minus 5 equal to 11. The first thing you have to do is you have to isolate this term here. This term here. How can you do it? How can you do that? I mean, send this one to the other side and divide by 4. So isolate the variable. So when you send this one to the other side, you get plus 5, so it makes 16, and divide both sides with 4, and you end up with this. So the next thing is you have to raise each side to power 3 over 2. This is 2 over 3, so you have to raise raise each side to the power 3 over 2. And when you do that, as you see, this is an even number here. So this is even. So when it is even, then we automatically have absolute value. So this is the absolute value. And okay, let's see how this is equal to 8. So 4 to the power 3 over 2 is, okay, you can do it several ways. I mean, one way is to write the definition of it. This is 4 cubed. This second root of the 4 cubed. This is cubed as square root of 64. This is 8. Or you can say this is 4 to the first half, to the half power, then third, and this will be 2. 2 cubed is equal to 8, so we get the same thing. And then after this, we have 2 possibilities for x. This is one of them is 8, one of them is negative 8. So you write them, and then, okay, here in this procedure, we have to check the solutions here. It's not checked, but we have to check them. So put them in here and check it again. It's negative 8. 2 over 3 is equal to, okay, negative 8. You can write it this way. Okay, it's 2 squared cube root, and this is 64 cube root, and this is 4. Yes, it satisfies this equation. If it satisfies this one, so automatically it will satisfy this one. And 8, in the same way, you can calculate it's equal to 4. So these, after checking them, we conclude this solution set is negative 8 and 8. Now let's see another example. In this example, it's giving the power of a binomial here, that 2 over 3 is equal to 4. So we will do the same thing. We will raise both sides to the power 3 over 2, because this is 2 over 3, and we raise it to 3 over 2. And then we look at here again, this is again what? This is again even. So if it is even, then this one, this is equal to the absolute value. So as you see, this is absolute value. And then we know how to calculate this from the previous slide. This is 8. And okay, this is how we can calculate this. This is one way to do it, or like you can use the definition of it. So it's 4 cubed square root. This is again 8. You can do both ways. Now the next thing here is, if its absolute value is equal to 8, then we have 2 options for this. This one of them is it might be plus, and it might be negative. So 2 options give you 2 solutions. Okay, solve this one, send this one here. When you solve, you have 2 answers, two solutions, and then we have to check them in the equation. Okay, you can put them here and check the solutions. I mean, check the equation, and look at here. This 11 minus 3, 2 over 3, and then it's 8 to the power 2 over 3. When you calculate this one, you will see it's 4. This is how you can do this. So this is the definition of the power here. So it's third power of 64, the third root of 64, which is 4. And you can do the same thing for negative 5. Here it's negative 5. This makes negative 8, and negative 8 means second power, and to take this third root, this gives you a third root of 64, which is 4 again. And then we check them, and the solution set turns out to be negative 5 and 11. And so we say, yeah, the solution is negative 5 and 11. Let's look at that problem here. Now, this problem is a little different than the others, because we have 2 different powers here. These are fractions, but these are fraction rational exponents, but they're different. So some students do it this way. I want to warn first. Okay, mathematically nothing wrong here, but the wrong thing is here. Again, this one here, the distribution of this 3 to 1, 3, and it's here, this is wrong. I mean, this is okay, but the distribution is wrong. Okay, you cannot have this. Don't do it. Don't do it. I mean, the proper way of doing this, doing such thing, is to see one important thing. This one important thing here is this one. X to 2/3 is equal to x to the 1/3 squared. So this is a quadratic equation whose variable is x to 1/3. So you can write it this way: x to 1/3 squared minus x to 1/3 minus 8. Now you can use a variable if you want, like for example, u equal to x to 1/3. Then it becomes u squared minus 2u minus 8. And then you can calculate the variable. You can factor it, and then it will give you a solution, two solutions, and then get back to x again. And then solve it for x, and we know how to do it. Okay, now but in the slide I think we don't use u, so this is how to do it. Or if you don't want to use u, it's okay. You can try to do this without u, like u. No need to use u. I mean, if you see that everything clear, then you can go to the next level, find the solutions, and the solutions. Okay, the x to the 1/3 is equal to 4, x to the 1/3 is equal to minus 2. And then the next thing you have to do is you have to take the 3/1 and 3/1 here. And as you know, this is an odd number, so if it is odd, you can directly say this is equal to x. And it turns out to be x is equal to 4 cubed. And let's do the same thing for this. This is odd, so this turns out to be x. And this one here, sorry, this is 3/1, sorry, either 2 to the 3rd power, which will be -8. So now we have two solutions here. Okay, we have 64 and -8, and then we check them in the equation. You can put them here and put them here and check them. Okay, I mean, I will not do it, but you can check. Okay, do it. Okay, check them. Check them in the equation. Then you will see they're satisfying it, so I'm not doing it. So the solution set will be -8 and 64. Thanks for watching. That's it.